students, welcome to Sunil's tutorial. I'm Sunil Merwani and today we'll be doing this chapter called as time value of money. Now guys, this chapter has a lot of formulas, so leave the first page blank for formulas and then start writing. First let's see the formulas. I'll write the formulas on the right hand side. Present value is future value into discounting factor. Future value is present value into compounding factor. Discounting factor is given by the formula 1 upon 1 plus r raised to t. Right? Compounding factor is given by the formula 1 plus r raised to t. Right? Initially, let's start with these four formulas and see how do we do the sum. Let's see question number 5.1, page 156. Yeah, you want to ask me something? Compounding factor is 1 plus r the whole raised to t. Right. Now let's see this. They're saying that Shashikant deposits 1 lakh rupees with the bank. Right? He is depositing the money today, so the present value is 1 lakh. Shashikant deposits 1 lakh with the bank, which pays 10% interest compounded annually. Right? So they are saying that R is 10%. 10% means 10 upon 100, which is nothing but 0.1. For 3 years. N is equal to 3 years. How much would he get on maturity? That means after 3 years, how much will he get? I want to find out future value. How much would he get on maturity means I want to find out future value. Future value is nothing but we said present value into compounding factor. Present value is 1 lakh into compounding factor. 1 plus 0.1 raised to t. T is 3. Compounding factor is given by the formula 1 plus r raised to t. So this is going to be 1 lakh into 1.1 raised to 3. Now guys, on the calci, when you are doing this, you press 1.1 into, go on pressing equal to till the time your counter reads 4.
1.331.
Yeah. So this is 1 lakh into 1.331. Right? So 133100. So he'll get 1,33,100 on maturity at the end of 3 years.
T is the time, right?
Yeah, T is the time period.
You write N to the come to know N number of years.
N or T, right? Let's see another formula, guys. I can also say that future value for a particular amount is determined as amount 1 plus r raised to t minus 1 upon r. Right? Where A is the periodic cash payment. A is the periodic cash payment. Right? Now here 1 plus r raised to t minus 1 upon r is called as the future value interest factor. Future value interest factor. This is nothing but 1 plus r raised to t minus 1 upon r. Reason why we call this way is because you have a table for this. Future value interest factor table you have. Right? Of A for a periodic amount. Right? Okay. Let's try to see this. Guys, can we see another sum? Let's see illustration 5.2. 4 equal annual installments. I said A stands for periodic investment. So you are making a periodic investment of 5,000. 4 equal annual payments of 5,000 are to be made into a deposit account that pays 8%. R is 8%, which is nothing but 0.08. What is the future value of the annuity and at the end of 4 years? So T is 4 years. Every month I am depositing 5,000 rupees, not every month. Every year I am depositing 5,000 rupees. At the end of 4 years, how much will I get? So I can use this future value of annuity formula. Future value of annuity is given by the formula. Future value of A is A 1 plus R raised to T minus 1 upon R. A is 5,000. Now 1 plus R raised to T minus 1 upon R, you have a table. Can you just look above the sum? They've given you a table. Since the rate of interest is 8%, you will look in the 8% column for 4 years. For 4 years, so you will say this is into future value. This is your nothing but future value interest factor. Future value interest factor at the rate of 8%. So 5,000 future value interest factor at the rate of 8%. 8% for 4 years is 4.5061. So when you multiply this, this will give you 22,530.50. So at the end of 4 years, if you deposit 5,000 every year for 4 years at 8%, at the end of 4 years, this is what you should get. Fine. Now, how do I double my amount? For doubling the amount, there are two rules. One is called as Rule 72 and the other is called as Rule 69. Let's try to see this. Illustration 5.3. If the interest rate is 10%, right? They've given you that the interest rate is 10%. In that case, what are the doubling periods of the investment at this rate? Right? Now, as per rule of 72, the doubling period is given by the formula 72 divided by R, right? So 72 divided by R, rate of interest is given to you as 10%, so 7.2 years. So if I use the rule of 72, I'll be able to double my amount in 7.2 years. Fine. Now, you have another rule which is called as the rule of 69. As per rule of 69, the doubling period is given by the formula 0.35 plus 69 upon R. So this is going to be 0.35 plus 69 upon 10. That's 0.35 plus 6.9, which will be nothing.
6.935.
Yes, 6 point. How?
6.935 is the answer.
How? 6.9 plus 0.35 is not 6.935. It's nothing but 7.25. Right? So you will double your amount in 7.25 years. Right? Can you write these rules on the formula sheet also, guys? Right, rule of 72 says that doubling period is 72 divided by R, and rule of 69 says that doubling period is nothing but 0.35 plus 69 divided by R. Fine. Next, let's move on ahead. Now, so far, I was investing the same amount for n number of years. Let's see illustration 5.5. 5.4 have we done? Let's see 5.4. Illustration 5.4. Find the present value of rupees 50,000. Right? They've asked you to find out present value. That means obviously this 50,000 has to be future value. So future value is given to you as 50,000 received at the end of 4 years. N is 4 years at the rate of 12% interest compounded quarterly. Now guys, when the interest is compounded quarterly, right, what you have to do is divide the rate of interest by the term in which it is compounded. If it is compounded quarterly means you will divide by 4. That means my rate of interest becomes 3% per annum, right? If it is compounded quarterly, that means 4 years will become how many quarters? Whatever is the time period multiplied by the compounding period will become 16. N will become 16. Now, we already know that present value, we have, do we have a formula for present value? Present value is nothing but future value into discounting factor. Present value is nothing but future value into discounting factor. Future value, discounting factor we've said is nothing but 1 upon 1 plus R the whole raised to T. Right? Now, this is nothing but like how we have a future value interest factor. Similarly, you have present value interest factor. This is nothing but future value into present value interest factor at the rate of 3%. Now, this particular table, guys, is given to you in the textbook on page number 170. Can you all please open to page number 170? Right, on page number 170, this is my present value interest factor. Look at 3% for 16 years. 3% for 16 years is nothing but 0.6232. 3% for 16 years is 0.6232. Someone please multiply this. How much does this come out to?
31,160.
31,160. Fine, do we get this thing clear? So I'll just write this down. This is also called, guys, 1 upon 1 plus R the whole raised to T is also called as present value interest factor. Right? Let's move on to another sum, guys. Illustration 5.5. They've given you that Mr. Shah has invested 50,000 on a Xerox machine on 1st Jan 2002. He estimates net cash income from Xerox machine in the next 5 years as follows. At the end of 5th year, the machine will be sold at a scrap value of 5,000. Advise him whether his project is viable considering interest rate at 10%. Okay, they give you the data year 2002, 2003, 4, 5 and 6, right? Cash inflow. Cash inflow is given to you as 12,000, 15,000, 18,000, 25,000 and 30,000. These are my cash inflows. Now, have they given me the rate of interest? Yes, they've given me the rate of interest at the rate of 10%. So, present value interest factor. Why am I using present value interest factor? Because this 12,000 I'll get after 1 year. This I'll get after 2 years, 3 years, 4 years and after 5 years. I want to know its present value, right? present value interest factor at the rate of 10%. Please open your present value interest factor table. It's on page 170. At the rate of 10%, please find out the present value. It is 0.9091, 0.9091, 0.8264, 0.7513, 0.6830, 0.6209. This is my present value interest factor. So in that case, present value is going to be how much? How do I get present value? Cash inflow into present value interest factor will give me my present value. So my present value of inflow will be 12,000 into 0.9091, which is 10,909, 15,000 into 0.8264, which is 12,369. Sorry, not 69, it's 96. Then 18,000 into 0.7513 is 13,523. Then 25,000 into 0.6830 is 17,075. 17,075. Now in the final year, your cash inflow is not 3,000 but 30,000. Moreover, they have given you that at the end of the 5th year, you will be selling the machinery for 5,000. So plus 5,000. So at the end of 5th year, you will not get 30,000. 30,000 you will get cash inflow. Plus you will be selling the machinery for 5,000. So the net amount that you will get at the end of 5th year is going to be 35,000. Multiply that by your present value factor, which comes to 21,732. When I add all this, I'll get my total present value, that is 75,635. That is going to be my net present value. Now, if I consider 10% interest rate, the present value of all future cash inflow is 75,000, right? My present value at the rate of 10%, my present value of all future cash inflow is 75,635, right? Now, if I keep the money in the bank at interest rate, right, at the rate of 10%, right, the net cash flow at the rate of 10%, my net cash outflow. How much am I investing in the machine? 50,000. As on today, I am investing 50,000. As on today, if I got all my money, I would have got 75,000. Since I am going to get more money than what I am going to invest, therefore I am going to buy the machine. Right? I can say, since present value of all cash inflow is greater than cash outflow, therefore project is viable. That's how you come to know that the project is viable, right? Next, let's see this. Now, so far we had now it is quite possible that you may have invested different annuities for different time periods. So in which case, my present, let's see another formula, present value of annuity for time period T is given by the formula A 1 plus R raised to T minus 1 upon R 1 plus R raised to T. Right? This is called as your present value interest factor for annuity. Right? Now, let's see this. Let's try to understand this or explain this to you with the help of a sum. Can we see illustration 5.6? They have said that what is the present value of 4 years annuity. So they have given you that time period is 4 years. What is the present value of 4 years annuity of rupees 8,000? So the annuity that I am investing, every year I am investing 8,000 at 12% interest. Rate of interest is 12%. Right? Now, let's see this. Present value of annuity for 4 years. Now, present value of annuity. I could have said that I can use either the 5th formula or the 9th formula. Right? I'm going to show this to you with the help of 9th formula. I can say that present value of annuity is nothing but annuity into 1 plus R raised to T minus 1 upon R 1 plus R the whole raised to T. Right? Do we get this in here? Now, all I need to do is, now this 1 plus R raised to T minus 1 upon R into 1 plus R raised to T is nothing but present value interest factor, is nothing but your present value interest factor. The reason why I did not use the 5th formula is because there the future value was given to you. Here I want the present value. The 5th formula, similar formula, but it gives you the future value of annuity. I want to know the present value of annuity, and that is the reason why I am using this formula. Right? At the rate of 12%. Please open your present value interest factor table. Your present value interest factor table is on page 170. 12% for 4 years. 12% for 4 years is nothing but 0. No, I want cumulative because I want the amount. This is on page 172. Present value interest factor of annuity. Present value interest factor of annuity, it's there on page number 172. 12% for 4 years is 3.0373. Annuity is 8,000. 3.0373. Right? So when you multiply this, you will come to know this is 24,298. So at the end of 4 years, your present value of money that you have saved today is going to be 24,298. Right? Do we understand the difference between the 5th and the 9th formula? 5th formula is future value, 9th formula is present value. Right? That uses future value interest factor, this uses present value interest factor. Let's see illustration 5.7. They've said that an investment of 40,000 is to be made on 1st April provides following cash inflows. Right? They've given you two alternatives. Which alternative would you prefer if the investor expects 10% return? Right? Let's draw the table first. Date 1st April 03, 1st April 04, 1st April 05, 1st April 06, right? Alternative 1. Cash inflow. The cash inflow is given to you as 20, 10, 10, 10, 20,000, 10,000, 10,000 and 10,000. This is the amount I will get after 1, 2, 3 and 4 years. Let's find out its present value, right? Let's find out the present value interest factor for this at the rate of 10%, right? Present value interest factor at the rate of 10%. Page number 170. At the rate of 10%, it is nothing but 0. Guys, please see the table. 0.9091, 0.8264, 0.7513, 0.6830, right? So in that case, when you multiply this, you will get your present value. Present value is going to be 18,182, 8,264, 7513, 6830. Right? When you add this comes to 40,789. So the present value of alternative 1 is 40,789. Right? Now 40,789 is, that means my present value of all cash inflow is 40,789. Cash outflow to buy this particular machine is 40,000. Since cash inflow is greater than cash outflow, therefore project viable, right? Then same way you calculate for alternative 2. First, once you calculate, first thing you have to find out whether the alternative is viable or not. If both the alternatives are viable, whichever has higher present value of all cash inflow will be selected. I'm leaving the sum half. I've only calculated for alternative 1. I want you all to calculate for alternative 2 on your own. Fine? Yes? Next, let's see illustration 5.8. A finance company has introduced a scheme of investment of rupees 40,000. The returns would be the returns would be 8, 9, 10, 11 and 12,000 in the next 5 years. The returns would be 8,000, 9,000, 10,000, 11,000 and 12,000 in the next 5 years. The indicated rate of interest is 10%. Compute the present value of the investment and advise regarding the investment. Present value interest factor at the rate of 10%, right? They give you 10%. So look at page number 170, it is 0.9091, 0.8264, 0.7513, 0.6830 and 0.6209, right? Now I can find out my present value. Present value is going to be nothing but 7273, 7438, 7513, 7513, 7451. When you add all this, you will get 37,188. Now, the present value of all cash inflow, present value of all cash inflow is 37,188. Cash outflow in the project is 40,000. Right? Now, since cash inflow is less than cash outflow, therefore project not viable. Fine, do we get this thing clear? Next, let's see another sum, guys. Let's see sum number 5.9. Illustration 5.9. They are saying that the shares of Riddhi Limited are quoted at 102 on 1st April 2002. The price rose to 132 rupees on 1st April 2005. Dividends were received at the rate of 10% on 30th June every year. Cost of funds was 10%. Is it worthwhile investing considering the time value of money? Now year 1, 2 and 3. They've given you for 3 years data because you have bought the shares on 1st April 2002 and finally you want its value on 2005. So 3, 4 and 5. Right? This is for 2003, 2004 and 2005. Right? Cash inflow. Now, dividend of 10%. Dividend is always paid on face value. My face value of Riddhi Limited is 10 rupees given to me. 10% on 10 rupees is 1 rupee. 10% on 10 rupees is 1 rupee. Right? 10% on 10 rupees is 1 rupee. Plus, in the year 2005, I am selling the shares for 132 rupees. Now, present value interest factor. Present value interest factor is 0. At the rate of 10%. They've given you 0.909. They've specifically given you 0.826, 0.751. So you can find out your present value. 1 into this. This is going to be 0.909, 0.826. This is 133 into 0.71, which is 99.883. Right? So your present value is nothing but 101.618. When you add all this, so your present value of all cash inflow is 101 rupees. How much is your cash outflow? How much did you buy the share for? Your cash outflow is 102 rupees. Since I'm getting net present value to be negative, that means my present value of cash inflow is less than the present value of cash outflow. Therefore, it is not advisable to invest in these shares. Right? Do we get this thing clear? Right. We'll stop this here for the day. Thank you very much.